If you're watching this on your phone, time is literally flowing differently for you than it is down at sea level. Black holes have been photographed. There are planets wandering the galaxy with no star at all. And the part of the universe we can see is 93 billion light-years across. How can that be? Buckle up. Today we're counting down 10 things about space that will blow your mind. Number 1. The part of the universe we can see is 93 billion light-years wide. The observable universe is astonishingly vast, about 93 billion light-years in diameter, even though the universe itself is only 13.8 billion years old. At first, this seems contradictory. If light has been traveling since the beginning of the universe, shouldn't the farthest things we can see be just 13.8 billion light-years away? The surprising answer lies in the fact that space itself has been expanding ever since the Big Bang. When we observe distant galaxies, we're seeing light that left them billions of years ago. While that light was on its journey toward us, the fabric of space stretched, increasing the distance between those galaxies and us. As a result, although the light may have traveled for 13.8 billion years, the galaxies that emitted it are now about 46.5 billion light-years away in any given direction. This radius defines the observable universe, giving it a total width of roughly 93 billion light-years today. This co-moving distance is different from the simple light travel distance because it accounts for the ongoing expansion of the universe. The expansion rate is described by the Hubble constant, and precise measurements of the cosmic microwave background, or CMB, the faint afterglow from the Big Bang, have allowed scientists to calculate both the universe's age and its size with remarkable accuracy. It's important to note that the observable universe is only the part we can see. Beyond that, the universe may extend much farther, possibly infinitely. The vast size we measure today is a direct consequence of the dynamic, stretching nature of space-time itself. Number 2. When you look into the night sky, you're looking back in time. Every star and galaxy is a time machine. Andromeda, the nearest big galaxy, is 2.5 million light-years away. So you see it as it was when early humans were just figuring out stone tools. With the James Webb Space Telescope, we're now seeing galaxies from the universe's first 300 million years. One record-setting galaxy, Jade's Z14-0, is confirmed at redshift Z14.3, meaning its light left when the cosmos was only 2% of its current age. ALMA even picked up oxygen there, evidence of surprisingly rapid early enrichment. And in 2025, a team reported MOME Z14 in JWST data at Z equals 14.44, pushing that frontier a little farther still. The early universe was already busy building bright, complex galaxies. Mind blown. Number 3. Most of the universe is invisible. When we look into the night sky, it might seem like we're seeing most of the universe, but in reality, almost all of it is invisible to our eyes and instruments. The stars, planets, gas clouds, dust, and even you and me, all the matter made of atoms, are what scientists call ordinary, baryonic matter. Surprisingly, this accounts for only about 5% of the universe's total energy and matter content. The rest is far stranger. About 27% is dark matter, an invisible form of matter that doesn't emit, absorb, or reflect light. We can't see it directly, but we know it's there because of its gravitational effects, holding galaxies together, bending light from distant objects, gravitational lensing, and shaping the cosmic web of galaxy clusters. Without dark matter, galaxies would fly apart instead of holding their spiral and elliptical shapes. The largest share, around 68%, is dark energy, an even more mysterious component. Rather than pulling things together, dark energy acts as a repulsive force on the fabric of space, driving the accelerated expansion of the universe. Its discovery in the late 1900s through observations of distant supernovae revolutionized our understanding of cosmology. We still don't know the true nature of either dark matter or dark energy. Their presence is inferred from precise measurements of galaxy motions, large-scale cosmic structures, and subtle patterns in the cosmic microwave background, the afterglow from the Big Bang. It's humbling to realize that about 95% of the universe is dark to us, for now. The quest to uncover what it really is remains one of science's greatest challenges. Number 4. We've actually photographed black holes. For most of history, black holes were purely theoretical. Then in 2019, the Event Horizon Telescope stitched together radio telescopes across Earth to capture the first image of a black hole's shadow in the galaxy M87, a donut of superheated plasma orbiting a 6.5 billion solar mass monster. In 2022, the same global array imaged the one at the center of our own Milky Way galaxy, Sagittarius A1. Those glowing rings aren't the hole itself, they're light bent and lensed by extreme gravity at the brink of no return. We're watching Einstein's predictions play out at the edge of physics. Number 5. The universe rings like a bell. In 2015, detectors called LIGO caught the first gravitational waves, tiny ripples in space-time, from two colliding black holes. 2 years later, in 2017, LIGO and Virgo saw two neutron stars collide. Telescopes worldwide spun to the afterglow, a kilonova that forges heavy elements like gold and platinum. That means some of the gold in your jewelry was likely born in the catastrophic embrace of dead stars. Every detection since adds to this new sense we've gained, listening to the universe's most violent event. Number 6. There are thousands of known exoplanets. 30 years ago, we didn't know any planets beyond our sun. Now we've confirmed 5,983 exoplanets across nearly every category you can imagine. Lava worlds, super-Earths, mini-Neptunes, and even planets imaged directly. That tally is as of August 2025 and climbs monthly as surveys like TESS deliver candidates that get confirmed later. But here's the kicker. A vast population of rogue planets seems to drift through the galaxy without a parent star, likely ejected during chaotic youth. Recent microlensing work suggests there could be hundreds of billions of these free floaters in the Milky Way, possibly even outnumbering stars. Number 7. The coldest known natural place in the universe is a ghostly nebula. Space is an extremely cold place, with an average temperature of about 2.7 Kelvin minus 270.45 degrees Celsius, set by the faint heat of the cosmic microwave background, the afterglow of the Big Bang. Yet there is a place even colder, the Boomerang Nebula, a ghostly cloud of gas located roughly 5,000 light-years away in the constellation Centaurus. The Boomerang Nebula holds the record for the coldest known natural place in the universe, with temperatures dropping to just 1 Kelvin above absolute zero, minus 272.15 degrees Celsius. This makes it even colder than the vast emptiness of deep space. The extreme chill is caused by the dying central star at its heart. As this star sheds its outer layers, it ejects gas at tremendous speeds, around 500,000 kilometers per hour. In the process, the gas rapidly expands, and much like air cooling as it rushes out of a spray can, the expansion causes a dramatic drop in temperature. This phenomenon turns the Boomerang Nebula into a kind of cosmic refrigerator on overdrive, cooling itself far beyond the ambient temperature of space. Observations using the Atacama Large Millimeter Submillimeter Array, or ALMA, revealed the nebula's hauntingly low temperature and its distinctive bow-tie-like shape, which glows faintly in visible light but is much more prominent in radio wavelengths. The Boomerang Nebula is a striking reminder of the strange extremes the universe can produce, a dying star literally chilling itself to death, creating one of the most beautiful and eerie natural objects in the cosmos. Number 8. Neutron stars forge matter so extreme. Crush a massive star's core and you get a neutron star, a city-wide sphere packing more mass than the sun. Inside, matter squashes into bizarre phases. Simulations suggest the crust forms nuclear pasta, lasagna, and spaghetti-like arrangements of nucleons, whose shear strength could be up to 10 billion times stronger than steel. That's not sci-fi. It's what you get when nuclei are squeezed by gravity to densities beyond any lab on Earth. If you could somehow scoop a teaspoon of neutron star matter, you can't. Please don't try. It would weigh billions of tons on Earth. Number 9. Space sends us millisecond-long. They're called fast radio bursts, or FRBs, blinks of radio energy that last a thousandth of a second and can release as much energy as the sun emits in decades. Some repeat, most don't, and their exact engines are still debated. In 2023, astronomers traced FRB 20220610A to a source around 8 billion years away, the most distant FRB ever localized at the time. Each well-measured FRB becomes a probe of the diffuse gas between galaxies, letting us, so to speak, weigh otherwise invisible matter threaded through the cosmic web. Number 10. Space doesn't just bend your path. Einstein told us gravity and motion stretch and squeeze time. Satellites in GPS orbit run on clocks that tick a little faster than clocks on Earth because they're higher up in a weaker gravitational field, but also a little slower because they're moving fast. Special relativity and general relativity pushing in opposite directions. Net effect? About 38 microseconds per day of offset. GPS has to correct for this or your maps would drift kilometers each day. We've even seen gravitational time dilation near a black hole. Stars whipping around Sagittarius A* show the predicted gravitational redshift. Relativity isn't just a theory, it's baked into your daily navigation. Black hole images weren't the only firsts recently. Webb gave us the first clear CO2 signature in an exoplanet atmosphere, WASP-39b, opening a new era for sniffing alien skies. In the vacuum of space, ultra-clean, identical metal surfaces can cold weld, literally fuse on contact, so spacecraft parts are coated or designed to avoid accidental sticking. Space keeps humbling us. The observable universe spans 93 billion light-years, but that's just the part we can see. Beyond that horizon, the cosmos likely goes on and on. We're peering back to the first few hundred million years, finding galaxies growing faster than we expected. We've heard space-time ring and seen black holes silhouette themselves against their own hot light. We've confirmed thousands of planets and suspect billions more roam without stars. We found the coldest natural place, imagined the strongest material, and caught the universe whispering millisecond messages across billions of years. And all the while, Einstein's equations quietly make your GPS work. If that doesn't make you feel tiny and lucky at the same time, watch it again. If you learned something new today, drop a comment with the fact that hit you hardest, subscribe for more mind-bending space stories, and I'll see you in the next one.